today we're going to write equations and inequalities with variables on both sides. So we're going to be given a situation or a story, and we're to write the equation or the inequality. All right, so let's start reviewing different ways we can state mathematical operations for add, subtract, multiply, divide, and some keywords for the word equal. And then we're going to use those keywords to help us solve some problems. So if we were reading a word problem, what are some words that stick out that you would say, hey, I would add? What are some words? Some. Total. Anything else? All together. And anything else? Combined. Good. Plus is an obvious one, right? I hope so. Anything else you can think of? We can always add more. All right. What about subtraction? How would you know you would need to subtract? Take away. What about a loss of 10 yards? What word? Loss. Good. And we can always go back and add more. Let's go on to multiplication. What are some words there? Of. Good. 2/3 of a number. Each. Yeah. Product. What about if I said twice a number? Does that mean multiply? Yes. Yeah. All right, let's move on to division. What are some keywords there that would let us know we need to divide? Equally. Okay, so like split equally. So the word split. And then let's add that. Equally. What about in multiplication? I said twice. What would that be if it was division? Wow. Half. Got it. How would I know when I'm writing an equation, what's a word or words that would mean equal? Think about when we were solving equations. The variable equals. What's another word besides equals? Alike. Maybe.
The sum.
That would be add.
Is.
Okay, you said alike. Okay, so you may not see the word alike. You might, but the word same. Is that kind of what you were saying? Alike? Okay. Did somebody say? Is good. The variable x is 9. Okay, when you see is, it's equal. All right, so let's look at some examples. So right below, we have Hudson and Knox in a race. Hudson is running at a speed of 8.8 feet per second. Knox got a 30-foot head start and is running at a speed of 6.3 feet per second. How many seconds will it take until Hudson and Knox have run the same number of feet? So what do we know? What do we know about Hudson and Knox? Abby?
Hudson is running at a speed of 8.8 feet per second.
Okay. What about Knox? Good.
appropriate.
Okay, what you got? Any? There's something else we know about Knox. Yeah. What does that mean? What operation would that be? Yeah. What do we need to know? The value of x, right? What does the value of x? So our plan and our work is, what does the value of x represent?
The feet per second.
Okay. Feet per second. Is it feet or is it just seconds? Because we already have feet, right? So it would represent seconds, right? So how can we write this? How many seconds will it take until Hudson and Knox have run the same number of feet? So we have Hudson. We want them to run the same number of feet as Knox. What can we do now? Say that again. Good. Hudson. Good. Now, are we ready for our solution to determine what x is in seconds?
Yes.
Yeah. So this is your equation, and we already know how to solve equations, right? So let's practice that. What do we do?
Subtract 6.3 out.
Good.
Both sides.
Any good left? Now what? What's our next step?
5 plus 5.
Got it. 5 by 2.5. 30 divided by 2.5 is? Sam?
30 divided by 2.5 equals 12.
Okay, what does 12 mean?
12 seconds.
Good. X equals 12 seconds. All right, turn it over to the back. I want you to try one example with your table. You're going to use the keywords that we set and solve an equation for each of the situations below. So you can write an equation, you're also going to solve it. Okay, make sure that you're looking at number 2. All right, we'll have somebody. We have celebrity A has 400 followers on social media and is gaining $75 75 followers each day. Celebrity B has 1,000 followers on social media, but is losing 25 followers a day. How many days will it take them to have the same number of followers? Good. 400 plus 75x equals 1,000 minus 25x. Six what? We know what our numbers mean something. What does 6 mean? 6 days. Can we put that up there? Let's put some labels. Numbers have meaning now. Good. Let's give them one big clap. 1, 2, 3. All right, so we're going to do the same thing with inequalities. All right, so an inequality is the relation between two expressions that are not equal to one another. All right, so we have less than symbol. There's one keyword, right? We've done that one for a few years, right? What are some other words that might tell us less than? Below, right? What else? Smaller than? What about greater than? Good. Above. What else? More than. Larger than. All right, what about less than or equal to? At most. In this room, we're going to give you at most $10. You're hoping for $10 or even less, right? $5, $2, even nothing, right? Probably what it would be. What else? Maximum. Miss Green's going to give you a maximum of $10. So the most you're going to get is equal to $10 or anything less than, right? No more than $10. Be careful when it says at most and maximum, it is less than or equal to. Okay, so make sure you're kind of think before you write down an inequality, okay? All right, let's look at greater than or equal to. What are some key words there? We kind of started,
At least.
at least. The screen's going to give you at least $10, right? You're probably hoping for more than $10.
Minimum.
Minimum, good. The screen's going to give you a minimum of $10. That's exciting. Anything else? Second one. Is it more than?
No,
That
less
was
than.
that one, right? Say that again?
No less than.
No fewer than, yeah, same thing. No fewer than $10. Good. All right, so let's just practice writing simple inequalities at first. Carl has fewer than 7 hats in his closet. So hats, what's our inequality?
Greater than or equal to.
Has fewer than.
Less than.
Less than 7. We're good with that? Okay. Let's look at number 4. Adrian wants to spend a maximum of $250 at the grocery store. She wants to spend a maximum of $250. That's the max she has.
Less than or equal to.
Good. Less than or equal to 250. She could spend exactly 250, but it's going to have to be less than, right? Are we good with that? All right, so with your table, I want you to try the other 4 before we move on. Blaney grew at least 1 2/3 inches last year. What's your variable inequality?
Insurance is greater than or equal to 1 and 2/3.
Good. Number 3, Jamar can fit no more than 8 people in his car. Gabby.
Less than or equal to.
What's our number? Good. You got it. All right. Number 5, Theo's suitcase weighs more than 56 and 7,500 pounds. Oscar, what you got? Number 5.
Greater than?
You got it. Greater than what?
56 and 75.
Good. Number 6, Patricia drank no less than 22 ounces of water before lunch. Eddie.
Greater than?
Greater, no less than.
Greater than or equal to.
Could also be equal to, right? 22 ounces.
Oh,
We're good?
yeah.
All right, so write down below, okay? If you could cross out the solution, we will not be solving inequalities. All right? We're going to write inequalities to represent each situation below. We are not going to solve the inequality. You can just scratch that out if you would like. Ren and Abby are reading the same book for their English class. Ren is on page 100 of the book, and she reads 1/4 of a page each minute. Abby is on page 88 of the book, and she reads 1/2 of a page each minute. How many minutes will it take for Abby to have read at least the number of pages that Ren has read? So we have Abby. What's at least? What inequality is that?
Greater than or equal to.
Good. Greater than or equal to Ren. Okay, so let's fill in that first, and then we can write their own expression. So Abby is on page 88 of the book, and she reads 1/2 of a page each minute. Okay, so she's on page 88, right? She also reads 1/2 a page per minute. Are you good with that? Is it okay that I put a decimal? Yeah. And then we want it to be at least Ren. And what's Ren? She's on what page? Good. She's on page 100. In addition to she reads 1/4 each minute. There's our inequality. Not bad, right? Questions? So it's very helpful if we can write that first and then replace their individual expressions. All right, try this one with your table. And over to the back. Number 8, you're just writing the inequality with your table. Good. I is greater than T. Love it. 40 plus 18 1/4 x is greater than 124 plus 7 3/4 x. Let's give her one big clap. 1, 2, 3. Questions before we move on? Okay, so the rest of the problems in your packet, you have some on equations and then inequalities, and you can see we've already done some, right? Okay, so with your table, I want you to complete one equation and then do an inequality. Then go back and write an equation, then do the next problem. Are we good? And then we'll check and see how you did. Last call for questions.